Now we have to discuss about the conservative force and non-conservative force. So whenever the force is applied on a body, then the displacement is occurred in the body. So then only the work is done in such case. So now here forces are two types. So one is the conservative force and another one is the non-conservative force. So now we have to define conservative and non-conservative force and what are the basic differences between them. Now we have to discuss in this chapter. Okay, so if the work done by the force around a closed path is zero, what is the conservative force? So if the work done by the force around a closed path is zero, so then such force is called as conservative force. So work done. So whenever the force is applied on a body, if the displacement is occurred in the body, so then only the work is done on that body. So the total work done, so from the initial point and goes to some final point and again return come back to the initial point. So that means around a closed path, if the work done, the total work done is zero, so then whatever the force is applied in such case, that force is called as the conservative force. So that means the work done in this case, that in this conservative force case, so the work done is independent of the path. The work done is only depends on the initial and final positions of the path. So in this conservative force, so the work done is independent of the path, and in this conservative force, the work done is depends only on the initial and final positions of the body. So not depends on the path. So how it will be moved. So here, for example, the initial position of the body is A and the final position of the body is B. The initial position of the body is A and the final position of the body is B. So then if the body is moves initially from A to B like this, and then the body is moves from B to A like this. So but whatever it may be, the path is whatever it may be. So how long or how short the body goes from one point to initial point to final point, so we don't bother about the path. So only we can consider the initial and final positions of the body, so but not the consider how long or how short the path. So here now I will give a small example to how the conservative forces works here. So how it is independent of the path. So here A, B, C inclined plane. So I can draw here. So initially, so in first case, if a body is moves from point B to point C, directly, and so the height is how much, the displacement is how much, h. We can lift this body from point B to point C, and the displacement is how much, h. That means the height is how much, h. So here how much force we can apply, F. So then the work done. So then the work done in such cases, so F into S. F into S. S is the displacement, F is the force. So here, so F is how much, mg. F is how much, mg. Why? Because that is the weight of the body. F equal to ma, it is equal to mg, and it is equal to w, weight. So force or weight, both are same. So here mg means the weight of the body. So F equal to ma. In case of Newton's second law, so already we proved that F equal to ma. So in place of A, we can write G here. So why? Because gravitational pull is acting on that body. So that's why that is equal to weight of the body. So that's why F equal to mg we can write here. And how much displaced body, that means the height of the body is how much. So how much height we can move that body, h. So here the total work done in such case. So in first case the total work done is how much? So W equal to mgh. So now in the second case, so inclined plane. So we can lift the body, we can move the body in an inclined plane. So here we can lift the body directly some height h, but here we can follow this path, inclined path, but here we can directly follows the vertical path. So these both the paths are different, right? So now if we can move this body, so from this place to this place, so this mg, so here w equal to fs, w equal to fs. So but here f means force, so how much force is acting here? So that is mg sin theta. So here in an inclined plane, so the total weight of the body is acting in this direction, and the normal reaction force is acting opposite to the plane of the inclined plane, and here this resultant force mg can be divided into, so mg cos theta and mg sin theta. So now here we lift the body from here to up, so that's why here mg sin theta is acting in the opposite direction of the force. So that's why here how much force is, the force is equal to how much here, f equal to mg sin theta, and the displacement is how much here, ac. The displacement is how much here, ac, a to c. So the total displacement is a to c. So now we can write mg, and so from this triangle ABC, so what is the sin theta? So BC by AC, BC upon AC, BC by AC. So BC by AC, and again here AC is there, displacement is AC. So AC cancel. So now mg. So what is the BC? Height h. So that's why h. So in the second case also, what we get, mgh. In the first case also, what we get, final work done, mgh. So that means independent of the path. So the work done is same in the both cases, but the paths are different. So that's why in conservative force, the work done is not followed the path, it is independent of the path, it is only depends on the initial point and final point of the position of the body. So this is about conservative. The best example for the conservative force is gravitational force. So example is gravitational. So gravitational. So the best example for the conservative force is gravitational force. So now we have to look about the non-conservative force. For a non-conservative force, so the work done by the force around a closed path is not equal to 0. But in case of conservative force, so the work done by the force around a closed path is 0. But here for non-conservative force, the work done by the force around a closed path is not equal to 0. So such force is called as the non-conservative force. So in this non-conservative force, so here in this conservative force, it is independent of the path, but here in this non-conservative force, it is depends on the path. So it is depends, depends on the path. So for non-conservative force, it is depends on the path, but here in conservative force, it is not depends on the path, it is only depends on the initial and final position. The best example for the non-conservative force is frictional force here. So here the frictional force is depends on the path. Why? Because, so for example, a small little example we discussed here. In first case, here A to B, the body is displaced 10 meters distance. So against the frictional force. So if we can apply the force, then that body will be displaced in this direction, and the frictional force is developed in the opposite direction. So here in this case also we can apply the applied force in this direction. The frictional force is acting in the opposite direction of the applied force. Already we knew that. So in these two cases, so what we have to observe. So from A to B, here in first case only 10 meters is there, so that's why the frictional force is very less applied on the body. But here from A to B 100 meters distance is there, so more distance, then more friction and more heat is generated between the two surfaces of the bodies. So that's why here more friction is occurred, more friction is developed. But in first case, so the friction is less developed compared to the second one. So in another example, if in first case the surface is very smooth, but in second case if the surface is zigzag, so uneven surface is there, so then what happened, so in second case compared to the first case, in first case the surface is very smooth, but in second case the surface is uneven. So compared to the first case, in second case, so the surface is uneven, so that's why more friction is developed against the applied force. So that's why the frictional force is depends on the path. So that's why the frictional force is the best example for non-conservative force here. So but the best example for conservative force is gravitational force. So gravitational force is independent of the path, but frictional force is depends on the path. So this is the basic difference between the conservative and non-conservative force. So in your work energy power chart. సో చూసాంగా వాట్ ఈస్ ద బేసిక్ డిఫరెన్స్ బిట్వీన్ ద కన్జర్వేటివ్ ఫోర్స్ అండ్ నాన్ కన్జర్వేటివ్ ఫోర్స్. సో విత్ ఎగ్జాంపుల్స్. సో నౌ we will see the visualization of the conservative non-conservative force with examples. Okay, so conservative force ante మనకు తెలుసు, it is only depends on the initial and final position, but it does not depends on the path followed. ఓన్లీ ఇనీషియల్ పొజిషన్ నుంచి ఫైనల్ పొజిషన్ బాడీ ఎలా మూవ్ అయిందనే దానిపైన డిపెండ్ అవుతుంది, పాత్ మీద డిపెండ్ కాదు. సో ఇప్పుడు మనం ఎగ్జాంపుల్గా ఇక్కడ ఒక 5 kg మాస్ ఉన్నటువంటి ఒక బాడీని తీసుకున్నాం. అది 6 meters డిస్టెన్స్ని దాన్ని మూవ్ చేయడానికి ఇక్కడ జరిగిన వర్క్ డన్ ఫోర్స్ ఇంటూ డిస్ప్లేస్మెంట్ ఎంత 294 joules అనేది మనకి ఇక్కడ జరిగింది. సో ఇప్పుడు ఇదే బాడీని మనము సేమ్ 6 meters కిందికి మళ్ళీ పైకి, కింద నుండి పైకి, మళ్ళీ పై నుండి కిందికి, ఇలా 3 times మనం మూవ్ చేసాం. సో ఈ 3 కేసెస్లో మనకి ఇక్కడ జరిగిన వర్క్ డన్ ఫస్ట్ పై నుండి కిందికి 294 joules, మళ్ళీ కింద నుండి పైకి -294 joules ఇక్కడ వస్తుంది, ఎందుకంటే ద డైరెక్షన్ ఆఫ్ ద మోషన్ ఈజ్ అగెన్స్ట్ ద గ్రావిటేషనల్ పుల్. సో దట్స్ వై సెకండ్ కేసులో -294 joules వస్తుంది, అండ్ థర్డ్ కేసులో ఫైనల్లీ మళ్ళీ +294 joules వస్తుంది. సో ఇక్కడ జరిగిన మొత్తం వర్క్ డౌన్ +294 -294 +294, సో ఫైనల్లీ +294 joules వచ్చింది. అంటే ఫస్ట్ కేసులో ఎంత వచ్చిందో సెకండ్ కేసులో కూడా అంతే వచ్చింది. సో గ్రావిటేషనల్ ఫోర్స్ అనేది మనకి ఇక్కడ కన్జర్వేటివ్ ఫోర్స్ అని ఎగ్జాంపుల్గా చెప్పొచ్చు. సో ఇప్పుడు నాన్ కన్జర్వేటివ్ ఫోర్స్, సో ఒక బాడీని మనం పాయింట్ ఏ నుండి పాయింట్ బి వరకు సో మూవ్ చేసాం సర్ఫేస్ పైన. సో అక్కడ కొంత థర్మల్ ఎనర్జీ అనేది డెవలప్ అయింది, రెడ్ కలర్లో మీరు అక్కడ చూడొచ్చు. ఇప్పుడు అదే బాడీని 2-3 times నెంబర్ ఆఫ్ టైమ్స్ అటు ఇటు అదే సర్ఫేస్ పైన తిప్పాం. సో ఇప్పుడు మోర్ థర్మల్ ఎనర్జీ వచ్చి మోర్ హీట్ డెవలప్ అయింది అక్కడ. అంటే నాన్ కన్జర్వేటివ్ ఫోర్స్ అనేది నీకు పాత్ మీద డిపెండ్